Okay, dump the ice cubes in here.
Okay. Whoops.
Okay, now I would like you to fill that glass with ice cubes.
Okay.
Certainly full, right?
Yeah.
In fact, sticking over the top. Okay, next, I would like you to take these 2 glasses over to the sink and fill them both almost full of water. Then bring it back, okay? Okay. Now you notice I'm wiping off the table so there's not a drop of water on it.
Okay.
And I will wipe off this plate so there's not a drop of water on it.
Why?
Well, you'll find out in just a moment, because I would like you now to use this long medicine dropper and take water from there and fill this glass so that it's right to the very brim with water.
Okay.
Don't let it overflow, but get it right to the very top. Aha! That's it. Okay. Move these out of the way. Wipe everything up so there's no water anyplace. Now my question is, as the ice melts, will the water overflow over the top of the glass?
I think so.
Why?
Well, because like you have the water, and the water is full to the top, and then you have the ice also, and like I think while the ice melts, it'll just overflow.
Okay, that's one theory, and that's definitely a theory, right?
Yeah.
You know what a theory is. Well, there's another theory, which I would like to advance and see how you like that. As you know, ice expands when it freezes as compared to water. That's why ice floats, right?
Yeah.
Okay. So therefore, as the ice condenses, in other words, goes back into water, it should take up less space. Therefore, the water level will drop.
Okay, yeah, I see.
That's theory 2.
Yep.
Now, there's a third theory. Obviously, the volume of the water is taking into consideration the ice that we've got in there. So as it melts, it's not going to change at all, because the volume has already got that ice floating in it.
Okay, I see.
That's the third theory. Which one are you going to take?
Mine. My theory.
The first one?
Yeah.
That it's going to overflow.
Yeah.
Okay, now that's why I wanted to wipe up everything so there's no water around any place. We're going to let it sit there very carefully and melt. It'll take about 2 hours. Can we be back in 2 hours?
Sure.
And I promise I won't touch it.
Okay.
Okay?
Hi.
Hi, Karen. Ah, you're right on time. 2 hours. You're very punctual. Are you usually?
Most of the time.
Okay. There's the glass that had the ice in it. Don't touch the counter now.
It didn't melt.
And your theory was that it was going to melt and flow over the top, right?
Yeah.
And why was that?
Well, the ice, like, it was floating above the top of the glass, so I thought it would melt.
Okay. That was one theory. That was no good. Now, the second theory was that the ice expanded as it would change from water to ice, therefore took up less space, so that as it melted, it would take up less space, so the water level ought to drop.
Yeah.
Did it?
No.
So the third theory, you remember now I told you that as you added water to the ice and you got it all to float, the level of the water took into effect the mass of the ice.
Yeah.
And therefore, as it melted, that water level is going to stay exactly the same. And that's what happened.
Yeah.
Yeah, the entire global warming concept, climate change, melting ice caps, it's all bullshit, folks. It's all complete bullshit. As you can see, a little third grade test with ice cubes just kind of proves it, you know.